Imagine a forest so clever it doesn't wait for rain. It drinks straight from the air. Picture colossal trees along a misty coastline, their crowns lost in fog. These are cloud forests, rare ecosystems perched between dry land and ocean air. Here the air is cool and heavy. The ground, perpetually moist. Not from rain, but from water collected by the canopy above. It's a world sustained by a river of fog flowing through the sky. Trees here have evolved to drink fog, a real phenomenon perfected over millions of years. They don't fight the fog, they embrace it, turning mist into life for themselves and countless other species. This process is the heartbeat of the ecosystem. Without fog, these forests would vanish. The trees, undergrowth, and animals all depend on this delicate dance between sky and earth. It's a fragile, beautiful partnership, showing us how deeply everything is connected. Here, the air we breathe and the water we drink are part of a single, glorious cycle. Understanding this relationship reveals the intricate web of life that sustains our planet. What is fog? Simply put, it's a cloud that's come down to Earth, a mass of tiny water droplets suspended in the air. Fog forms when warm, moist air cools rapidly, causing water vapor to condense. These fog forests exist only in special places, coastal regions where cold, ocean currents meet warm land. Think of California, Chile, Peru, or the Canary Islands, where fog rolls in from the sea and sweeps inland. This advection fog is the lifeblood of these forests, providing water where rain is scarce. The fog moves like a living tide, transforming the landscape in moments. For plants and animals, the arrival of fog is as vital as sunrise. A cubic meter of dense fog can hold up to half a gram of water, insignificant alone, but immense in volume. Trees here have evolved to harvest this airborne moisture, turning haze into a torrent of fresh water. It's a perfect example of nature harnessing a subtle, powerful force. How do these trees drink from the air? Through a process called fog drip. As fog blows through the canopy, droplets collide with leaves and needles, clinging to their surfaces. Droplets merge, grow heavier, and eventually fall to the forest floor. This is fog drip in action. Every leaf and twig acts as a collector, creating a gentle shower even when skies are clear. The ground beneath these trees is often wetter than open areas nearby. Trees create their own rainfall, concentrating fog into water for their roots and the soil. The water seeps into the earth, replenishing groundwater and nourishing ferns, mosses, and fungi. Streams and creeks are fed by this process, supporting amphibians and insects. The entire ecosystem is hydrated by this ingenious method. By quenching their own thirst, these trees provide for a whole community of life. They are true keystones, sustaining their world with every drop. Fog drip is the quiet engine behind the forest's abundance. The coastal redwoods of California are the ultimate fog drinkers, giants that soar over 100 meters high. Their survival depends on fog, especially during California's dry summers when rain is almost non-existent. Fog provides up to 40% of their annual water intake, allowing them to reach breathtaking heights and live for millennia. Redwoods are perfectly designed for this. Their height lets them reach dense fog, and their flat needles maximize water collection. As fog-laden winds blow through, the needles comb moisture from the air, creating a steady shower below. Fog also cools the forest and blocks harsh sunlight, reducing water loss from leaves. This dual benefit, delivering water and conserving it, makes the system complete. Without fog, these ancient giants couldn't thrive. The redwood's mastery of mist is a perfect adaptation to their coastal home. Their relationship with fog is beautifully symbiotic, sustaining the entire ecosystem. It's a testament to nature's ingenuity and balance. The tools trees use to harvest fog are marvels of design. Redwood needles are arranged in flat sprays, maximizing surface area to intercept water droplets. Other plants, like those in the Atacama Desert, have leaves covered in tiny hairs or waxy coatings to trap and channel water. Some leaves act like funnels, directing water to the roots. Every aspect of their structure is tuned for water collection, a result of millennia of evolution. This principle has inspired human innovation fog catchers, fine mesh nets that harvest water in arid regions. These simple devices can collect thousands of liters of fresh water daily, providing a vital resource where it's needed most. Nature's solutions are not just beautiful, they're practical. By studying these adaptations, we find new ways to solve our own water challenges. The water collected by trees is the foundation of the entire forest ecosystem. Constant moisture allows mosses, liverworts, and lichens to thrive, creating a living sponge that prevents erosion. Fungi flourish, breaking down dead material and recycling nutrients for plants. Without fog, decomposition would slow, and the forest would starve. The abundance of water supports a rich web of animal life, from invertebrates to amphibians, birds, and mammals. Even high in the redwood canopy, mats of soil support ferns, shrubs, and unique creatures that never touch the ground. This elevated ecosystem, a forest within a forest, depends entirely on fog. Every layer of life, from soil to treetop, is linked by the water harvested from the passing clouds. Fog is the invisible thread that weaves this world together. In Chile's Atacama Desert, one of the driest places on Earth, lies a green oasis, Frei Jorge National Park. This isolated forest survives thanks to the Camanchaca, a dense coastal fog that rolls in from the Pacific. The trees and shrubs here are masters of fog collection, creating their own rain in a land of drought. Inside the park, the air is humid and the ground soft, while just outside, the desert is barren. The line between these worlds is drawn by the reach of the fog. Frei Jorge is a living museum, a relic of a wetter past, supporting unique animals like the degu and gray fox. For these creatures, the forest is a life-saving island in a sea of scarcity. It's a dramatic reminder of nature's power to create abundance in the harshest environments. Fog forests exist in a delicate balance, dependent on cold ocean currents, wind patterns, and predictable fog. Climate change threatens this balance. Warmer oceans and shifting winds could thin fog or lift it above the forest's reach. In California, summer fog is already declining, putting redwoods at risk of drought and wildfire. Deforestation destroys these habitats, ending their ability to capture fog and impacting local water supplies. Pollution can turn fog acidic, damaging trees and soil. Invasive species disrupt the ecosystem's balance, outcompeting native life. The web of life in fog forests is intricate and fragile, easily unraveled by these pressures. Protecting them means safeguarding both nature and the resources people depend on. The story of fog-drinking forests is a lesson in resilience and the genius of nature. Protecting these ecosystems preserves a unique part of our planet's heritage. We must be their guardians, supporting protected areas and addressing climate change. Every action, big or small, helps protect the delicate cycles that sustain these forests. Their fate is tied to the health of our world. Fog forests teach us that survival is about partnership, not domination. By protecting them, we safeguard both biodiversity and wonder. Let's promise to be better stewards, ensuring these misty realms endure for generations to come.